Welcome back, everybody. Today's lecture is going to be a continuation of some material that I talked about last week. This was several lectures back because in the meantime, we've been very busy with lab exercises. Last week, we had lab exercise 8, and I dedicated one lecture to getting ready for that exercise, and there was another lecture dedicated to sort of follow up to that. And then on Monday of this week, we did basically set up for this week's lab. So it's been a while since we have been talking about things other than labs, but in the list of lectures, going back several lectures back, in lecture number 21, I gave a lecture which was an introduction to some additional collection classes in the Java class library, specifically the tree set class and the tree map class. Now today's lecture is a follow-up to that earlier material, because in that earlier material, I just had enough time to sort of talk about broadly what these classes are, what you use them for, and to show a few very simple examples. Today, I want to sort of take this opportunity to show an extended example that makes use of these classes and that helps demonstrate the kinds of ways that you will use these classes in practice in solving a particular problem. Okay, so again, a quick reminder of what we're talking about here. We are talking about a set of classes in the Java class library that collectively are known as the Java collections classes. And these are all classes that are designed to store data in various ways and help you work with data in various ways. The most famous of these classes, the class that we've been working with quite extensively over the last couple of weeks, is the ArrayList class. If you're simply looking for a class that can allow you to store a list of items and work with that list of items, the ArrayList is almost always the best choice for that particular application. Now, having said that, there are other applications where you do still need to store some data, but because you have slightly different requirements for how you're going to be interacting with that data, you may want to choose an alternative class in some of those situations. All right, and in the earlier lecture, in lecture 21, I introduced you to two alternatives that you have at your disposal. One of these is the tree set class, which is used to store sets of things and as quickly and efficiently as possible answer questions like, here's an element, is this element in the set? And also add as quickly as possible, allow you to add new items to the set and remove existing items to the set. That's what the tree set class is optimized to do. Another class that we were introduced to in lecture 21 is the tree map class, which implements what we call a mapping relationship. And in a mapping relationship, you are basically setting up associations between two data items. One of the data items is what's known as a key, and the other is a value that's associated with that key. And the tree map class is designed to, as efficiently as possible, look things up. If you provide a key value for something you're looking for, the tree map will very quickly locate the entry for that particular key and hand you the value that is associated with that particular key. So this is used in many cases where you want to set up associations between different things, and it's designed to do that very efficiently. All right, so in today's example, we're going to be looking at a classic data storage and manipulation task, and we're going to discover quite naturally in the course of solving this particular problem that the tree set and the tree map classes will be helpful to us. So those classes are going to figure in the solution that we eventually write. All right, so let me now switch to the lecture notes for today's lecture and give you some of the background of the problem that we're going to be working with. All right, so the setting here is that we are imagining that we are writing software to support something like an online course, a set of tools that allow students to do coursework and submit their work. And we're going to be building a tool that will collect information that's generated by that system and organize it and present summary reports. Right? And specifically in the program that I'm going to be writing today, that program is going to be designed to read information about a set of quizzes that a group of students have taken. And we're going to be reading this information from a text file. And every row in the text file will have this format. The first thing in each row will be the name of a particular student in the class. The second thing will be a quiz number for a quiz this student has taken. And the third thing will be the score that that student got on that particular quiz. Right now, one thing that we're going to be assuming here is that when the students take the quizzes, they're going to be taking them in sequence. So a typical student will take quiz 1, quiz 2, and quiz 3, and so on and so forth. But beyond that assumption, we're not going to assume anything about how the quiz information comes in. In particular, because the students will be allowed to work through these quizzes at their own pace, what we may have in a given data set is some students working through the quizzes very quickly and other students working through the quizzes a little bit less quickly. All right, so here's a chunk of typical data from the text file that we're going to be reading from. And what you will see in the data file is you will see various students completing quizzes and getting scores for those quizzes. But most importantly, since different students are operating at different paces, these things are going to arrive mixed up in all kinds of different orders. So in a given block, you may have one student who's just getting around to completing quiz number 1. At the same time, there's another student who's further ahead and has completed quiz number 7. All right, so we don't want to make any assumptions at all about the precise order with which this information is going to appear in the text file. About the only thing that you can count on is that any given individual student will be working through the quizzes in sequence, but we can't make any assumptions about what the class as a whole is doing, because some students will be going through more quickly, others will be going through more slowly. All right, so that is the raw material that we're going to be working with, basically a list of quizzes that students have taken and the scores that they've received for those quizzes. Now, the end result of the program that we're going to be writing today is we want to write a program that will generate a couple of reports. And these reports will cover useful information that we would like to know about how the students are doing. All right, the first thing that we'd like to generate is a listing for each one of the students showing what their current average is. All right, so for the quizzes that they've already completed, we're going to compute the average score over whatever set of quizzes a particular student has completed, and we're going to present that average score as part of our information. Then the second report that we're going to generate is a report which is basically a progress report that lets us know which students still need to complete which quizzes. Right. So what we're going to do is from the data file, we're going to determine exactly how many quizzes we're talking about here. And then we're going to print a report for each individual student that says, okay, for this particular student, they have yet to complete these quizzes. All right, and that will also give us a quick sense for individual students' progress. So for example, if there's a student that has a great big long list of quizzes that they still need to complete, we'll know that they're a little bit behind relative to the rest of the class. And the other thing that this report will help us to pinpoint is instances where students may have, for whatever reason, not completed a particular quiz. They may have accidentally skipped over it. Right, so there's the possibility here that a particular student may have completed quiz number 1, and for whatever reason they haven't done quiz number 2 yet, and they've gone ahead and done quiz number 3. So in that case, there would be a missing quiz somewhere in that student's list, and we want to know about those things happening so we can contact that student and let them know that there's a quiz that they skipped over that they need to go back and complete. All right, so that is the overall goal of today's program, is to take the information that comes in the data file and organize it in such a way that we can quickly and easily generate these two reports, a report on what each student's average score is and a list of what quizzes each individual student still needs to complete. All right, so that is our overall goal. Okay, so now let's start thinking about this problem as programmers, and let's start designing a solution. The first thing to think about when designing any solution is to start by thinking about the data. You want to ask yourself questions about, okay, now what kind of data am I going to be working with? What is the best and most logical way to organize that data? And in thinking of ways to organize the data, you also want to look ahead to what you're planning to do with that data, which in this particular example is these reports that we need to generate. Right, so whatever choices we end up making about how the data is going to be organized in the application, we also have to convince ourselves that whatever scheme we use to organize the information will in turn make it reasonably easy to generate these reports that we need to generate. Okay, so the next step in the process is as soon as you start thinking about organizing the data in your application, you're naturally going to be led to think about creating some classes. Right? And in this particular example, there are two obvious classes that come to mind, right? And here's the beginnings of the structure of these classes that we know that we're going to need to write. Okay, so the first obvious class that comes up in this context is we need something that represents an individual student. Right? And the obvious things to say about this are that each student obviously has a name associated with them, and the most important thing about each student is that each student has a list of quizzes that they have completed. And what we need to record is which quizzes they took and what grades they got for those particular quizzes. All right, so here is a first draft of a class to represent a student that tries to capture these key requirements. Right, so obviously every student needs a name. We need a member variable for that. And then we need some sort of a mechanism for storing a list of all of the quizzes they have completed. Right? Now, there is no one best way to organize that quiz information. In fact, there's many different alternatives that you can imagine. One alternative, for example, would be to create something like a quiz object, which records the quiz number and the person's score. If you have something like a quiz object, what you would then do is you would maybe set up something like an array list and store a bunch of quiz objects in that array list. That is one potential approach, and that's a perfectly valid approach. Instead, the approach that I'm going to be taking today, again, because I'd like to be talking a little bit about sets and maps, is I'm going to view the need to store this quiz information as an opportunity to use one of our classes, namely a map class. Right? Because the other way you can think about this is that we're also, in a sense, dealing with an association, because here there is an association between a quiz number and the score that a particular student got on that particular quiz. All right, so if you phrase it that way, thinking of a quiz as an association between a quiz number and a score, another natural way to store all of that information is to instead use a map. All right, so what we're going to set up here is a map that uses the quiz numbers themselves as the key value for looking things up, and the score that the student got on a particular quiz as the value that is associated with that key. All right, so that's the specific choice that I've made for storing the quiz information. And as we'll see as we get deeper into the project, that actually turns out to be a reasonably workable way to do things. Okay, so as soon as you've made those basic decisions about how data is going to be organized in a particular class, the next thing to do is to start writing down some methods, right? And here's a list of 3 obvious methods that come to mind right away. The first, something that you're always going to have, is that whenever you create a class, you should immediately think about writing a constructor, right? Because again, the purpose of the constructor is to initialize whatever member variables you decided that the class would have. Right? And in this context, the obvious way to initialize a student is that when you first create a student, something that you will be guaranteed to know about them right away is you'll know that student's name. So you can count on having a student's name at the instant that you create a student's object. So you want to take that name as the parameter to the constructor and use that to initialize the name member variable. Right now, it's also the job of the constructor to initialize every one of the member variables that's listed here. So we also have the responsibility of initializing this grades variable. Right? And once again, setting up a variable for some sort of a structure is only half the story. The other half of the story is actually creating the structure itself, and that is the job of the constructor. All right, so here in the constructor, we're actually going to be creating the tree map at this point in time. And when you create a tree map, it automatically starts out empty. All right, and that's appropriate because at the instant that we create that student, we won't yet have any quiz information for them. So what all we'll be able to do is simply make an empty map at that point that will later be able to receive that information. All right, so now you always know that you're going to need a constructor. The next question beyond that is, are there any obvious methods that you can think of right away that this class needs to have? And here's a couple of examples of this. Obviously, because these member variables are private, in many cases, we're going to need to provide what are called accessor methods that allow you to access those things for whatever purpose. So for example, because the name is private here, for anybody who wants to know a student's name, we'll need to provide a method that allows them to do that. All right, so we have a method called simply getName, and that allows you to return that student's name for anybody who needs to know that information. All right, and then as for the map, something that we're obviously going to need to do along the way is, as we receive information about grades as they come in, we'll want to record those. All right, so we'll need a mechanism for doing that. So we need a method called record grade that will take a combination of a quiz number and a grade for that quiz and record that for this particular student. All right, and again, since we're dealing with a map, the primary mechanism for adding new entries in a map is the put method. And the way the put method works is you give it a combination of a key and a value, and it then goes ahead and stores that particular association in the map. That's the basic mechanism for adding more data to a particular student. Excuse me. Now, eventually, we're going to discover the need for more methods in this class, but at the moment, this is enough to get us going. This answers preliminary questions such as what are the member variables going to be, and let's begin the process of adding methods to this class by adding the methods that are obvious at this point. Later on, we're going to discover the need for additional methods, and we'll be adding those as we go along. Okay, so any questions at this point about the student class?
Can I re-clarify? Um, so the tree map, I know that it has a parent-child relationship. So
Mhm.
does the first like the first integer in those brackets refer to the parent, and the second integer refer to like both children, like a set of children?
No, the way that the tree map is organized is, it is, as you're saying, it's organized as a tree structure where the individual entries of the tree map have parents and children. Um, but within the tree map, each individual node represents one association. So each association will have both a key and a value in it. So for
Oh,
example, here, when I add a combination of a new quiz number and a new grade, both of those are going to go into a single node within that
oh,
structure. Okay, and the structure overall is organized as what we call a search structure. And the reason it's organized as a tree is that later when you go looking for a particular key, so for example, if you want to come back later and ask, okay, did the student do quiz number 4? To do that, you're going to have to do a search through the structure. And that's where the tree aspect comes in, because the tree is there precisely to make these searches run more quickly. So if you're looking for the node where the quiz number is 4, the tree structure will help you do that search much more quickly and efficiently.
okay, thank
Mhm. All right, and again, any other questions about this class before we go on to the next class? Okay, so now that we have a way to handle quizzes associated with an individual student, the next thing we need to deal with is the fact that, of course, what we're going to be working with is a group of students. All right, so we're going to need to develop a second class that is designed specifically for storing collections of students. All right, now, of course, I would like to call this a class, but unfortunately in Java, the word class is already taken for a particular purpose. So to prevent confusion, I'm not going to call this group of students a class. Instead, I'm going to be forced to choose a slightly different name for the class. So the name that I settled on for that purpose is I instead called it a roster, right? Because again, a roster is a list of people engaged in a particular activity. And that's what we have here. We have a list of students who are taking a course, right? So the second class I'm going to introduce is a roster class that stores information about a group of students. Okay, now, again, the first obvious thing to say about this is that we want the roster to be a list of students. One obvious way we could set that up is we could set it up simply as an array list of student objects. Right now, that would be perfectly fine for storing a collection of students. But the other thing going on, and another thing that's going to happen today, is at various points in time, we're going to need to access students by their names. And this is another case where using a map might actually be a good idea. All right, so what we're actually going to be doing here to store the individual students is we're going to be storing them in a map. And the map that I'm going to set up for that purpose sets up an association between the student's name and the student object that we are using to represent that particular student. Right? And one reason why that's going to be particularly handy is that when we start reading our way through the original data file, what's going to be happening is we're going to be reading individual lines in the data file, and the first thing you're going to see on a given line is a student's name. So one of the first problems we're going to have is, okay, now that I know the name of a particular student, can I get as quickly as possible to the object that I'm using to represent that student? Right, so that's an example where having a map would be very handy. If I have a map that associates names of students with the student objects, that will allow me to take a given name that has just come in from the text file and as quickly as possible locate the student object associated with that name. Right, so that's why it makes sense to use a map instead in this case to store all of our student objects, because maps make it very easy to look up things when you're looking up, say, people by their names. Right now, a second thing that I'm going to add to this class, which is a little bit less obvious, but turns out to be useful in the end, is I'm going to be adding a second member variable here, which is essentially a list of quizzes. Right now, let me explain in a little bit more detail why I need something like a list of quizzes. One thing that we can't assume ahead of time is that we know exactly how many quizzes we're talking about. Right, because what we're doing here is we're building a system, and very often when you build a system, you have to think in terms of the bigger picture, and you have to ask yourself, what are all the different ways that I might end up using this system? So for example, if I am building a system to manage this quiz information, I may find it useful, and as soon as I find it useful, I may want to apply it across a bunch of different courses that people are teaching. And there is nothing that says that any given course will have this many quizzes in it, right? So one course may have 6 quizzes over the course of a term. Another course may have 12 quizzes over the course of the term. So we don't want to make any assumptions ahead of time about exactly how many quizzes we're dealing with. What we want to do instead is we want to let the data file that we're reading basically give us this information as we go along. So one of the things that I'm going to be doing as I read the data file is each time I notice a different quiz being mentioned, I want to make a record of that so that when I reach the end of the data file and I've read all of the data, I'll be able to look back at my records and say, oh, it looks like this class had 6 quizzes in it because I only saw data for 6 quizzes. Or in another setting, I would look after reading all the data, I would say, oh, it looks like this class had 12 quizzes in it, because along the way I saw 12 different quizzes being mentioned. All right, so to keep track of the actual number of quizzes that have shown up so far in the data, I want to have some sort of a list for that purpose. All right, and because these quizzes are frequently going to be duplicated, if I give 6 quizzes in a class and there are 30 students in the class, that means when I read the data file, I could see potentially 180 different instances where quizzes are being mentioned somewhere in the data file. And many of these will be duplicates. You'll see, for example, all 30 students at some point or other completing quiz number 2. All right, so what we need is a data structure that allows us to track how many different quizzes we've seen. And this data structure also has to very gracefully handle duplicates. So if you're seeing a quiz mentioned more than once, you want to make sure in whatever list you eventually end up, that quiz appears only once in the eventual list. Right, so that is an application where a set actually turns out to be a very useful thing to do, because one thing that sets do very well is they handle duplicates very nicely. If you put something in a set and you come back later and try to put a duplicate of that thing in the set class won't allow that. It simply won't allow you to enter an item more than once. So it automatically, based on its normal behavior, deals with duplicates. Once a particular quiz has been mentioned once in this list and you try to do it a second time, the quiz simply won't take it the second time. So that will end up giving a list of all of the quizzes that have showed up in the data file, and each quiz will be mentioned exactly once in that list. That's something that a tree set does very well. Okay, so that's why I made these choices about putting these two data structures within the roster class. And at this point, the only obvious other thing to do with the class is to give it a constructor. And again, the purpose of the constructor is to initialize our member variables. And if our member variables are things like collection classes, we have to go ahead and set up those collection objects. All right, so that is what the constructor is doing at this point. Okay, any questions about the roster class? Okay, so now let's start to put all of these things to work. All right, so what I want you to keep in the back of your mind is a quick sense that we're dealing with two classes. We've got students and we've got rosters. And remember that the student class stores a combination of a person's name and a list of their quizzes. And the roster stores a list of students and a list of which quizzes have appeared so far in the data file. All right, so keep those concepts in the back of your mind. Let's now dive into the mechanics of some things that we need to do, starting with the first obvious step, and that is reading the data from the input file and organizing that data into a collection of objects. Okay, so what we're looking at here is a method. This method is eventually going to be embedded in the roster class, because the roster is where we can see the big picture. There we have all the students and we have access to all the students. So this is going to be a method that gets added to the roster class. And this is the method that is responsible for reading the data file and storing all of this information in the roster and setting up students as necessary. Okay, so fortunately, this is something that we've done many times before. We now have seen many examples of programs that need to read data from a text file. And what we're going to see here are some fairly standard things. So for example, here's a scanner that's designed to read from that text file. The usual routine when you're reading data from a text file is to have something like this while loop that says, while there is still more information left to be read, let's process it. All right, then on each trip through the while loop, we are going to be processing one block of data from the text file, and these blocks are organized into names, quiz numbers, and grades. All right, so the first thing to do is to read those three pieces of data and then go to work storing that data. Okay, now the first question we're going to have here concerns the name that we just read, because especially early on in the process, we may be encountering this person's name for the first time. So the first question we'll have is this a person we've seen already, or do we need to make a new student to represent this person? All right, so for that, we go to the roster, which is a map, and we ask it whether or not the map currently has an entry for this particular name. And for that purpose, there's a handy method. It's called contains key, which will allow us to go to a map and ask it whether it has an entry for that particular name. And if it says no, that lets us know that we haven't yet created a student for that particular person. And we need to do that. All right, so we'll go ahead and make a new student object for that person. We will then use the put method to put the combination of that person's name and their student object into the roster. So now we're guaranteed to have an object that represents that person. Okay, and whether or not we needed to make a new student or not, once we've gotten past that step, we can then go back to the roster and say, okay, I just read a person's name. Can you quickly find me the student object that is associated with that particular key? All right, and the method that does that is a get method. You simply pass it the key that you're looking for, and it will find the associated value, which in this case is a student object. All right, and then as soon as you have access to the student, you can then record that grade. As we've seen already, the student class has a method for recording a grade. We simply pass it the quiz and the grade, and that gets recorded in the student object. All right, and finally, the last question we're going to have here is, because we're reading information about a particular quiz, is if this is the first time that particular quiz number has been mentioned, we'll want to make a note of that in our list of quizzes that we've seen. So the last question to ask here is this a quiz that shows up already in our list of quizzes? And if it's not there now, we need to go ahead and add it. All right, so set up a simple if statement that checks to see if the list of quizzes already contains this quiz, and if not, we will add it to the list of quizzes. All right, and then when the job is done and we've read all the contents of the data file, we'll then have all the data that we need to work with organized into a roster, and then individual students with quiz information in them. All right, so any question here about the code for reading the data from the text file? Okay, so once we've read the data from the text file, and if we've done a good job designing our classes, at that point we'll have all the data that we need to work with in the form of a collection of objects. And our next job is to do whatever work is necessary to perform whatever tasks we need to perform with those objects, right? And in this setting, the tasks that we're talking about include generating these two reports that I mentioned at the beginning of the discussion. Okay, so what we're going to do next is we're going to add a series of methods both to the student class and to the roster class that will help us generate these reports that we want to generate. All right, so the first two methods that we're looking at here, these are methods that I'm going to add to the student class, and these will help us answer questions related to individual students. All right, so for example, one of the things we need to do is we need to print a report which for each individual student tells us the average of the quizzes that they have taken so far. So for that purpose, I've added a method called quiz average to the student class that will allow you to compute the average of a student's grades. Okay, now this is a thing that we've done many times in the past. This is going to involve computing a sum of all the student scores and then dividing that by how many scores we have. That's a fairly standard piece of logic. The only slightly unusual thing in this case is I've also taken this opportunity to use an enhanced for loop. Because the grades that we're looking for are stored in a map. That map is called grades. And the scores themselves, they are basically the values part of that map. Right now, a neat trick that you can do with a map is you can call this method. It's called the values method. And when you call that, you get a list of only the values that are stored in the map. Right, and that's exactly what we want here. What we want is just a list of the quiz scores without the quiz numbers. Right, so by using the values method, I can get a list of just the scores, and then I can write an enhanced for loop that iterates over all of those scores. And then all I have to do is do a grand total of all of those scores in a loop structure. And then when I've got that grand total, I just have to divide that by how many scores I have, and I've got myself an average. Okay, so once again, using a map makes these things relatively straightforward to do because again, the map class offers a nice collection of methods to do the kinds of things we need to do here. Okay, now another method that we're going to need to write is for each individual student, what we're going to want is we're going to want to print a report of which quizzes they are missing. All right, and to help us do that, I'm going to imagine passing in a parameter to this method, which will basically be a list of all the quizzes that have been mentioned anywhere in the data set. All right, and the question we're going to want to answer is, for this particular student, which of these quizzes have they taken and which quizzes have they not taken? Right, so to do that, all we simply have to do is set up a loop that iterates over this list of quizzes. And for each quiz that's mentioned in that list, we need to go to that student's record and see if they have an entry for that particular quiz. Right, and we'll answer that question by going to the grades map and using the contains key method, which allows us to search in the map and ask, do you have an entry for this particular key? All right, so once we know the quiz number, we use that as a key into the map, and we can ask the map, do you have an entry for this particular quiz? And if it says no, that means that that quiz appears to be missing for that particular student. So we need to print some information about that. Basically, what we're going to do is print the student's name, followed by the number of the quiz that they're missing, and that will generate the report that we're trying to generate here. Right, and because I want to have the flexibility of either dumping this report to a text file or potentially printing it on the screen, the way that we're actually going to be printing this is whoever calls this method is going to be giving me a print writer to work with. And that print writer can be set up either to print things to the screen or dump them out to a file. Regardless of how that print writer is set up, we can just use the print writer to print the message that needs to be printed here. All right, so that's how the output will eventually make its way to where it needs to go. Okay, so these are two methods that are going to get added to the student class that will help with part of the task of printing reports about students. All right, so any questions about either of these two methods? Okay, so these two methods, they go a long way toward helping us build the reports that we need to build. To finish the story, we need to also add two methods to the roster class that will actually generate the reports, right? And because we have two reports that need to be generated, I'm going to be creating two methods that will go into the roster class. One of these is the thing that's going to be printing the report on which students are missing which quizzes. That's simply going to involve setting up a loop that iterates over all of our students. And for each of our students, we're going to be using the print missing method to say, okay, here's a list of quizzes you're expected to have finished. Here's a print writer that you can use to print your stuff. Go ahead and tell me for this individual student which quizzes that student is missing. All right, and then once I've done this for every single student, I've finished my report. All I have to do is close the print writer, and that will send the report wherever it needs to go. All right, and then the print averages, that's very similar. Once again, what we're going to set up here is a loop that goes over all available students. And for each individual student, what we're going to do is first print their name, and then we're going to print information about their quiz average. All right, and since the quiz average is going to come to us in the form of a double, if we simply just printed that double, it would look a little bit ugly. So to clean that up a little bit, I decided to use the printf command, which we talked about much earlier in the course, because the printf command gives me a way of controlling the way that that double gets printed. In this case, I want to print it basically as a double with just one digit after the decimal point. And then I also want to print a line break in there as part of the print. So that will allow me to control the way that the averages get printed. Okay, so with these two methods now, we have solved the main problem that needs to be solved. We now have mechanisms for generating the two reports that we need to generate. And fortunately, what we discovered along the way is that the classes we set up and the way that we organize data within those classes was done the right way, in that the setup that we have here allows us to do everything that needs to be done in a relatively straightforward way. Okay, so any questions about these two methods here that are printing the reports? Okay, and then the last thing is to show everything put together here. So here is the NetBeans project. Here is the data file that we're going to be reading from. And the data file is fairly long because we have a group of students. I guess the students are named A through L. And it looks like we have a set of 10 quizzes that we're dealing with. So there's quite a bit of information here. All right, so there's the original input file. Here now is the project with the two classes that we created, the student class and the roster class. And the last thing that needs to be done is that we need a main method. And the natural place to put that main method is in the roster class. This is the method that will actually set up the roster object, read the scores, and then print the two reports simply by calling the appropriate methods in the roster class to do the work. All right, and then once that main method is in place, we can go ahead and run the project and see that it appears to be doing the right thing. Here are the reports being generated. So first is the report on everybody's quiz average, and the second report is the report on missing quizzes. And again, the main reason why a lot of these students appear to have missing quizzes is because the text file is basically a snapshot in time. And at the time that we took this snapshot, not everybody has yet had an opportunity to make it through all the quizzes. So that's why a lot of students will be like student C here, who is most of the way through. It looks like they still have to complete quizzes 8, 9, and 10. But the other thing the report is telling us here is it looks like that student skipped over quiz number 2. So we need to get in contact with that particular student to let them know that they're missing an earlier quiz and they need to make sure and go back and complete that before they finish up everything here. Okay, and one final remark to make about this. This is sort of a neat side effect of using tree sets and tree maps, is that by default, when you start storing data into either a tree set or a tree map, another nice thing that these data structures do for you is they automatically sort things for you without you even having to ask for this. Right? So for example, when I printed the report of quiz averages, all I simply did was to iterate over all of the students within my roster. And since the roster is a tree map that uses the students' names as the key, it will automatically sort our collection by those names. So when I ask for that report to be printed, it's automatically going to get printed in alphabetical order by student's name without me having to say anything, basically asking for that to happen. That comes along for free, and that's a side effect of using a map. All right, and likewise, when we are printing the report about missing quizzes, the list of quizzes that I set up is in the form of a set, and that set also automatically sorts the quizzes into order. So when I iterate over that set and go looking for missing quizzes, the quizzes, when they get mentioned, they're going to be mentioned in order of increasing integer values. Right, so that way, when I look at the report for any given student, that report is automatically sorted in order of increasing quiz numbers. There's nothing that I had to do here to tell the program to do that. That was just a happy side effect of the fact that I stored these quiz numbers in a set, because sets automatically, as a side effect of storing a collection of information, they will automatically sort that information for you without you having to say, now sort these things. Okay, so that is the end of today's example. And again, the purpose of this example is to demonstrate in a more sort of a real world setting the kinds of things that sets and maps can do for you. These are a handy addition to the collection classes that are available in Java. So now when it comes time to store a set of data items, you no longer just have the array list as your only choice. You now have the option of using a set or a map, whatever is appropriate for your given problem. And as this example demonstrates, some of these new classes come along with a lot of really nice advantages that make them useful for many applications. Okay, so with that, we're out of time for today. And when we come back on Friday, we'll have a few more examples. The other thing to keep in mind is that we're also approaching the end of the term. Next week is 10th week, and something that I very much want to be doing next week is wrapping up the course and also getting everybody positioned for the final exam. So we're only going to have one or two more of these sort of lectures. There's going to be one on Friday and probably one on Monday. But after that, we're going to switch into a mode where we start preparing for the final exam. And we're going to be doing some review. We're going to be doing some additional examples that are aimed toward preparing you for the final. All right, so stay tuned for that. That's coming later this week and early into next week. All right, so that's all for now. And I'll see some of you back in lab tomorrow and everybody else back here on Friday.